Hello students, before we start with whatever is written on the board, let us go back and see what we did in the last lecture. 3 questions were asked in the last lecture. The first one was, which is the element in the periodic table which is devoid of, जिसमें नहीं है, neutrons नहीं है. First of all, is there any element in the periodic table devoid of neutron? And if at all there is, which is the element? The answer to that question is, there is only one element in the periodic table which does not have any neutron in its nucleus, and that is hydrogen. 1H1, that is what we call it. We write it as 1H1. And I hope you know what is this. This is H is hydrogen. This 1 stands for, that is A, atomic mass number. This is Z, which is atomic number. Atomic number is nothing but number of protons, and atomic mass number is number of protons plus number of neutrons. From this we understand that hydrogen 1H1 will have 1 proton inside the nucleus, and obviously the number of neutrons will be 0, because if I substitute number of protons is equal to 1 over here, the number of neutrons will come out as 0. So that is the answer of the first question, that is there any element which is devoid of any neutron? The answer is yes, there is, and the answer is hydrogen. Of course, there is another isotope of hydrogen which is 2H1. This is called as deuterium, and this isotope of hydrogen which is 2H1, which will have number of protons equal to 1 and number of neutrons equal to 1, because if I substitute number of protons 1 over here, the number of neutrons will definitely turn out as 1. But this exists to its maximum, more than 99% is 1H1, and therefore we conclude that there is an element in the periodic table without any neutron being present inside the nucleus, and that is hydrogen. So that was the answer of the first question. We'll be going back to the periodic table in details later on. The second question which I had asked was, what do you mean by isotones? What we did was, we did isotopes, we did isobars, and I asked you to find out what are isotones. Let us quickly revise isotopes. That is what I've written over here. This is 1H1, 2H1, and 3H1. These are the isotopes of hydrogen. These are the isotopes of hydrogen, because isotopes are defined as, isotope of the same element is defined as the element with same atomic number but different atomic mass numbers. 1, 1 and 1. It is having same atomic number but different atomic mass number. So this is isotope. Then we saw the example of isobar. The example of isobar was this one, that is potassium. K stands for potassium, that's the Latin name is kalium. Potassium, I just reverse that order. This is going to be 40, this is going to be 19, this is going to be 40, and this is going to be 21. So now it's in proper place. Potassium 4019 and calcium 4020. These two elements are isobars of each other. This is isotope, and this is isobar. What do you mean by isobar? Isobar have same atomic mass number. Isobars have same atomic mass number but different atomic numbers. And I told you to find out what do you mean by isotones. Isotones are the elements having isotones are the elements which have the same number of neutron. For example, if I say sulfur 3216 and I say phosphorus 3115, sulfur 32 16 and phosphorus 31 15. Let us check that out. Number of protons plus number of neutrons is 32. Number of protons 16 plus number of neutrons, that is 32. The number of neutrons are 16 in sulfur. The number of neutrons are 16. You can easily work out for phosphorus. Phosphorus atomic mass number is 31 and atomic number is 15. Therefore, number of protons plus number of neutrons will be 31, out of which 15 are protons. So, number of neutrons will be 16. And because they have the same number of neutrons, they are called as isotones. Isotones will have the same number of neutrons. This is what isotones are. Fine. The third question. The third question was about the valency, OUS and IC valency. So we'll be going back to the last question later on. First, let us see what this is. This is 11th standard, first lesson, first page. First lesson of 11th standard is some basic concepts of chemistry, and the lesson starts with this because some of the students had commented that this is 8th, 9th, 10th standard revision which you are taking. So what about 11th standard? So this is 11th standard stuff. You will understand one very significant thing, that if you know whatever was taught in 8th, 9th and 10th standard, this becomes very simple because every time it is one step further. So what is this? Matter. Fine. What is the definition of matter? We are going to see this inverted, this is called as inverted tree structure, and many of the lessons can be studied with the help of this pattern. This is the pattern which is used for synopsis of a lesson. Matter, anything which occupies space and has mass. Anything which occupies space and has mass is called as matter. Fine. Something we have studied in physics and something we have studied in chemistry. So we have divided it into two categories: pure substance and mixtures. We know what do you mean by pure substance. Pure substance will be composed of only, it's of only one type. For example, it's pure gold. When we say it's pure gold, it is nothing but gold. If we say this is pure water, then it is nothing but exclusively water. So I write over here compound. So pure substance is a substance which has the same constituents throughout. Pure gold will have nothing but gold atoms throughout, and pure water will have nothing but H2O molecules throughout. Fine. This can be further divided into element and compound. So what is a compound and what is an element? So we have seen that elements in the periodic table, we have seen there are 118 elements in the periodic table. So the element, when we go on cutting an element, what we land up at is an atom. And when we go and cut a compound, when we go and cut a substance, we land up at something we call it compound. Elements can be divided as metals, non-metals and metalloids. Elements can be divided into metals, non-metals and metalloids. What are metals? Metals are the ones which lie on the extreme left of the periodic table, we say. Metals are the substances which are electropositive. Metals are the substances which can give an electron. Metals are lustrous. Metals are generally solid, of course excluding mercury. So metals are the elements in the periodic table having typical characteristics of being electropositive, having the ability to donate an electron, and so on and so forth. So what are non-metals? Non-metals are the elements. Non-metals are the elements which have the reverse property of a metal. They are electronegative. They are going to accept an electron. They are going to take the electron. Of course, so metal will react with non-metal, so we'll get a compound, because metal is going to give an electron, it's electropositive, and non-metal is going to accept that electron because it's electronegative. So Metal is electropositive, it's giving the electron. Non-metal is electronegative, it is going to accept an electron. What about a metalloid? We study possibly the best metalloid. We have a silicon and another one is carbon. In 11th standard you have a lesson on this. This is referred to as chemistry of carbon compounds, because our entire body structure, whatever we eat, whatever we dress, it's carbon based life form. What we are is a carbon based life form, and whatever devices, electronic devices are around us, it's a silicon based life form. Human being, trees, everything is a carbon based version, and silicon based is all the artificial intelligence stuff is coming up from silicon based stuff. Fine. So smallest particle of a substance is referred to as a compound. Smallest particle of a substance is referred to as a compound. Then what is the mixture? It is you take two substances, you put them together, but remember, if you take sodium and you take chlorine and you put them together, they will react. Sodium will give an electron, chlorine will accept it, and what we will get is sodium chloride. That is what we eat. That is the salt, what we call as. Mixture is not sodium and chlorine taken together. Mixture, we take two substances, we put those two substances together, and the two substances will not react with one another. That's what is a mixture. Mixture में दो substances जो mix किए जा रहे हैं वो एक दूसरे के साथ react नहीं होंगे. Okay, so that's what mixture stands for. There are two types of mixtures. One is a homogeneous mixture and another is a heterogeneous mixture. Fine. What is a homogeneous mixture? The mixture which is in single phase is a homogeneous mixture, and the mixture which is in more than one phase is a heterogeneous mixture. Fine. What I understand from that is, if I take suppose oil and suppose I take water and I put it together and I stir it or something like that, they seem to merge. But if I allow it to stand, थोड़ी देर रख देने के बाद oil and water separates. It's a heterogeneous mixture. That's what, it's more than one phase. Don't think liquid है, oil भी liquid है, पानी भी liquid है, it will be homogeneous mixture. No, it will not be a homogeneous mixture. It is a heterogeneous mixture because they separate out. On standing, oil and water will separate out. जबकि when two substances, it can be solid, liquid, gas, no problem. But when they mix together to form a single phase, we refer to it as a homogeneous mixture. So this is basically the first page of 11th standard syllabus. We'll be going back to the remaining stuff later on, but because in the flow this part was there, so I have taken this. Now what we have to understand is the third question which I had put across. The third question was, what is valency rather, and does elements have variable valency? So let us see first of all what is valency. I was talking about sodium and I was talking about chlorine. We have adjusted the entire syllabus flow in a typical manner where slowly and gradually we do one concept and we apply it. Sodium atomic number is 11. Chlorine atomic number is 17. So you have studied in your previous classes. The electronic configuration is going to be 2, 8 and 1. Over here the electronic configuration is going to be 2, 8 and 7. These are inner orbit electrons. This is what we call as the valence electron. This is what we call as valence electron. Now there is a rule which is called as octet rule. Every element in the periodic table, of course excluding hydrogen and helium because they are the first two elements, every element in the periodic table tries to get 8 electrons in its outermost orbit to become stable. So is this stable? No, because it has 1 electron in its outermost orbit. Is chlorine stable? Even chlorine is not stable because it has 7 electrons in the outermost orbit. every element in the periodic table tries to get into a configuration where it has 8 electrons in the outermost orbit, thereby achieving stability. फिर उसके बाद वो react नहीं होगी, तो ये reaction होगा क्या इसका, ये react करेगा कि yes, it's very reactive. How it will react? So it has two, we can say there are two possibilities. To complete octet, it will give away the last electron. So of course the outermost orbit will be this now, and the outermost orbit will have 8 electrons. Or it will accept 7 electrons. It will give away this 1 electron, so that the outermost orbit will have 8 electrons. Or it will accept 7 electrons, because then 1 plus 7 will be 8 and octet will be complete. So it can have two valencies, I'll say. It can have one valency 1 because it can give 1 electron, and it can have valency 7 because it can accept electron. What it does is, obviously this is not going to happen. This is very difficult for sodium. As I told you, it's electropositive. It's going to give away 1 electron. So the valency is 1. Okay, and sometimes we will be going ahead with something called oxidation number. The oxidation number will be +1 because it is giving away something negative. So oxidation number will be +1. We won't be going right now into it. We'll just say, okay, this is having valency 1. It can have valency 7 as well, but it's absurd to say that it can accept 7 electrons. See, on the other hand, this one, chlorine, 2 electrons in the first orbit, 8 electrons in the second orbit, and 7 electrons in the third. Again, to complete the octet, there are two possibilities. Possibility number 1 is it is going to donate all the 7 electrons which are there in the last orbit. The second possibility is it is going to accept 1 electron. The second possibility is it is going to accept 1 electron. Common sense tells us this is not going to work. So we say they are electropositive and they are electronegative because this is going to accept 1 electron. इसकी भी valency 1 है. So we say this will be +1 and this will be -1 sometimes, because it gives away 1 electron and this accepts 1 electron. So what I am trying to make you understand is, in case of sodium chloride, sodium is electropositive, it gives away 1 electron, and chlorine is electronegative, it accepts 1 electron and forms a bond which is called as sodium chloride, which is an ionic bond which is formed by when electropositive element gives an electron or more than 1 electron and the electronegative element accepts it. There is a complete transfer. There is a complete transfer of electron from sodium to chlorine. It's an ionic bond. The question was, this has valency 1, only 1 valence. This is having valency 1. There are 2 valencies, of course there are 2 valencies, but this valency is absurd. And the question was, are there elements in the periodic table who actually practically show 2 valencies? And the answer is yes. The elements which are there over here, you see the periodic table, you see the 2 towers over here, and then something like these elements over here. These elements are called transition elements, and transition elements show variable valency. Transition elements will show variable valency. Let us take an example and understand this and how we call these elements as. Let us take an example. Let us call this as ferrous chloride. Let us call a compound as ferrous chloride and ferric chloride. Let us call a compound ferrous chloride and ferric chloride. What I am writing is ferrous. Ferrous is iron, and chloride, okay, Cl. FeCl लिख रहा हूँ मैं सिर्फ यहाँ. Ferric chloride मैं FeCl लिख रहा हूँ. How am I going to go ahead and know how many elements of iron and chlorine are there over here just from the name? See this very properly. This is OUS and this is IC. This is very tricky. This iron has atomic number 26, and yesterday we saw that in the mole concept it has atomic mass number 56. It comes in the variable valency category, which is called as the transition element category. This is referred to as D block. That is what we will be studying. Ferrous chloride and ferric chloride Iron shows two valencies. One is 2 and 3. Valency shown by iron is 2 as well as 3. The lower valency, please remember, the lower valency is called as the OUS valency, and the higher valency is referred to as the IC valency. So ferrous chloride is FeCl2, ferrous chloride is FeCl2, and ferric chloride is FeCl3. Ferrous chloride is FeCl2 and ferric chloride is FeCl3. What is the problem then? It's very simple. It looks very simple, but if I ask you what is the formula of cuprous oxide and cupric oxide, what is the formula for cuprous oxide and cupric oxide? Please don't misunderstand. Valency 2 is cuprous, valency 3 is cupric. No, that's not the case. In case of cuprous oxide and cupric oxide, copper, as we know, element atomic number 29, again lying somewhere over here, followed by zinc over here. This element shows variable valency, and the variable valency of copper is 1 and 2. It's not 2 and 3. So why it comes up as 2 and 3 in case of iron, and why it is 1 and 2 in case of copper, we'll be studying that. But what we have to understand basically, cuprous oxide and cupric oxide, this is OUS over here and this is IC over here. The lower valency is OUS valency, so 1, and the upper end valency is the IC valency. So I understand cuprous oxide is Cu2O, because oxygen will have valency 2, copper has valency 1 because it is OUS valency, so we need to take 2 copper atoms. On the other hand, cupric oxide will have the formula CuO. On the other hand, cupric oxide will have the formula CuO. So very significant in this is the lower valency. So I write over here, the lower valency is OUS valency and the higher valency is the IC valency. Fine. Now the question. So I had asked you this question. Now sub question to this is, you have to find out certain compounds with OUS and IC name. Okay. Just as an example, I will tell you. One is mercurous chloride and mercuric chloride. So you have to write down the name as I have written over here. Then you have to write down the formulation of the two compounds. The formulation of mercurous chloride and mercuric chloride. Then you have to find out the valencies. So one compound, homework, mercurous chloride and mercuric chloride. Another compound, you can find out the valencies and OUs, stannous chloride and stannic chloride. Stannous chloride and stannic chloride. Mercurous chloride, we take chloride because it's very simple, valency is 1, and mercuric chloride. You have to write down the formulation and you have to understand what are the valencies which are shown over here. So this is what the homework is. We have made a small change. The WhatsApp which was sent to you, the link which was sent via WhatsApp, we are stopping that. We have got our own website. The name of the website is Ideal Coaching Classes, and what we are doing from today itself, what we have done is all the demo lectures and all the demo videos are now available on the website. Okay, every day We will be refreshing the website as we do between 11 and 12, 11 a.m. to 12 noon, and the videos will be available on the websites. Just make sure that henceforth the videos will be made available on the website. You visit the website regularly, you will find a demo lecture on the right hand side top corner. You have to click that, and the 3 videos which are there will be made available on day-to-day basis. Please watch those videos. There are few more lectures, so we are right in the middle of the demo lecture session. We'll be continuing with the demo lecture session for 4 more days, that is Thursday, Friday, Saturday, Sunday, and then we'll be having a small session with your parents. By that time, what you are supposed to do is you are supposed to religiously watch these videos and subscribe to the Ideal Coaching Classes channel, so that whatever new videos we are making, whatever animated videos we are going to have when we start with the 11th standard syllabus, they are available to you at your fingertips. The name of the website is idealcoachingclasses.com. You visit that and the demo lectures are there. Thank you so much. Have a nice day.